Hey everybody, just in case you're not familiar with summation notation, I want to give you an idea of how big this number is we're dealing with today. So the very first term, there's going to be 9 sum-ins here. So for I equals 1, okay, we would have 23. If you put 1 right here where the I is, that would be 23 to the 3rd power, right? Okay. Of course, we're not going to write all 9 of them down. We'll leave out. We'll just put the first and the last. Now for I equals 9, if you put 9 right here where I is, you get 2 times 9 is 18 plus 1 is 19, so you get 23 to the 19th, right? So again, a massive number, and our task is to divide this entire number in by 25 and see what the remainder is. Again, impossible if you're trying to do it normal everyday way with, actually expanding the thing out and trying to get a real Hindu Arabic number. Okay. So again, we're supposed to find the remainder when n is divided by 25. Now, if you want to think of that in terms of, and this is the way I'll be looking at it, we're trying to consider this in modular arithmetic in this way. We want to find some r less than 25. And we use this notation modulo 25 like this. Mod abbreviation, right? And it's very common to envelop that in parentheses. Okay, so we're looking for an R, because when you divide anything by 25, you get a number between 0 and 24 inclusive, right? So that's the idea here. We'll be looking at it in this way, okay? So our goal is to reduce it modulo 25, as I think this is the official language to describe what we're doing. All right, now the first big discovery is this part right here. 23 is equal to 25 minus 2. You see, math's not hard. All right, and notice that when you square this, you're just utilizing this identity a squared minus 2ab plus b squared. And you're also noting that the very simple truth that 25 is congruent to 0 mod 25. 25 is congruent to 0. 25 minus 0 is divisible by 25, right? So 25 is congruent to 0 mod 25, right? All right. Now I'm going to leave out the modulo a lot. I'll try to put it in when it's absolutely necessary. But notice that's why all that's left here is you get 23 squared is congruent to 4, okay? That's the takeaway here. 23 squared is the same thing as 4. Let me just, hopefully it won't decrease the legibility here. So 23 squared is congruent to 4 mod 25. Now that's super useful fact, because a general term in this sequence looks like this. 20 in the series looks like this. So using laws of exponents, you can rewrite this like this. 23 squared, remember, 23 squared is congruent to 4. You see how the 23 right here became a 4. And also there's a 23 left, right? That's 23 to the 1st, which explains this 1 right here. Okay? So we got a reduction for the general term in the series. All right, and the rest of this is just filling in the blanks. I mean, putting it everything where it belongs, right? You see the K just changes to an I here, and this is our original problem. Okay, so we're looking pretty good here. Now, so this is just writing it all down. There's no other way. There may be some other way to do it. I don't know. I don't know if there's another way. But notice that these numbers here, 4 plus 16 is 20, plus 64 gives you this 84. Nothing else happened here, folks. Okay? So this is just some arithmetic, some tidying up. Okay? Now let's keep going. Now we're actually going to get down to the reduction modulo 25 now. And I'd like to show you what we really did here that made this happen. We exploit the fact, and if you don't notice them like this, you're just stuck on these kind of problems, really. You could still do it, but it's a little bit easier. If you don't, I mean, these numbers are so large, what are we going to do, right? We're almost like the same problem we started with, right? But if you notice that 4 to the 4th, 4 raised to the 4th power, I guess it's not going to let me do it. 4 raised to the 4th power. Don't know what's wrong with this damn thing, man. That's equal to 256. Okay, that's equal to 256. But that is congruent to 6. right? Mod 25. And that's clear, isn't it? Okay. So that very useful modular arithmetic reduction idea, you can see what happened here. 4 to the 4th got replaced by 6 here. Okay. 4 to the 4th got replaced by, and I don't know why this damn thing, this is a Microsoft product, you know. That 6 is the same. I don't know why it's disappearing. What a piece of crap. Okay. And y'all, the rest of the way, it's the very same. It's the very same, okay? And so it's a lot of work here, but you get it reduced down to manageable numbers, right? So this would be congruent to 2, okay? Congruent to 2, folks. And I don't know why this goddamn thing is disappearing on me, folks. But anyway, you can see that this is congruent to 2 mod 25. I'll say it, then I'll write it up here and then complain to hell like hell to Microsoft. So y'all, what we get right here is who knows, man? Look at that. What a piece of dog shit. Okay, n is congruent to 2, folks. And I apologize, not really for cursing, because Microsoft sucks. They have way too much of the market share, you know, for no good reason that I can see. But n is congruent to 2, and it's based on this fact right down here, that we got it down to 552, okay? So when you divide 25 into this, you get a remainder of 2, okay? So anyway, that is the solution, folks, and thank you for viewing.